Hi, my name is Alessandro Angelosi and that's a video tutorial coming from cgcookie.com for Max Cookie. Past time we talked about Pyrocluster 3.5 from Cebas, and we made just an introduction to understand how we can play with it and which are the basic features we can use in 3ds Max. This time we continue to talk about this plugin, and we'll start to talk about the feature doing a complete shot and complete scene. So this time we'll try to work on something related to clouds rendering using Pyrocluster, and we'll see how we can approach to the problem and how we can solve some topics related to this problem. So let's go in 3ds Max. The most simple thing we can do is to prepare a background, and that will be really simple. So let's think about to have a gradient. So we go inside one material and we set gradient ramp. Let's rotate by 90 degrees. Okay, so let's work on the first color. We'll do something really simple, so let's go for example, for something like that, and the second color will be something more intense, and the other color will be something like that. Okay, let's go inside the environment, and we set this gradient ramp as environment map, and we say to use an instance. Okay, so let's go there, and let's use just a sphere just to have something inside the rendering. We set the render to use the skyline. Okay, and let's set the resolution to 900 and 400 and lock the image aspect. Let's render, and we have the thing. We have to go there, and we have to say about the mapping to use not the texture mapping but the environment mapping as a screen. So this time we have to rotate again to -90, so we have the right position, and render, and that's our render. I'd like to move a little bit this one. Okay, so we see more something like that, and maybe also another little bit. So you see we have just in this area. Obviously it's not so precise, but we need just maybe to make another kind of color. Let's check. Okay, let's save the scene in the right folder. Okay, and let's do 3ds Max, particles, cloud with Pyrocluster. Let's copy the name, and we can call the scene in the same way. Okay, so we have our basic environment. We can light the scene, and to light the scene actually we can just put a target. Let's create a camera from this point of view for the moment, so create camera from view. Okay, let's go there, and we can set the lighting. Let's think about something like that for the moment. It's just for the testing purpose. Let's move it there, and we can move the light to the center of the sphere. Okay, and there we can set to shadow map. We set the intensity to 1 dot, let's say 35, and we'll have a bigger area there and an overshoot. So if we have something out, the the hotspot will be illuminated, and then we say to the shadows there to have shadows to the atmosphere. So when we'll have the atmospheric effects done by Pyrocluster, we'll have also the shadows for it. Okay, now we have to shape in any way the shadows. We can have different way. We can use objects and then, for example, sphere, and then use a particle system to attach to the sphere, and or we can use a simpler way, and we can see the lighting there for the moment. And maybe we can have, let's use a fill light just to finalize this part of the work. Okay, and this light will remove specularity. We'll set in any way a color similar to the skylight, and we set really low, and we see the result. You see we have a little bit of reflectivity there. You can use more light to have a more precise lighting there, but it's just to have a test lighting inside the scene. Okay, so the most simple particle system that can be useful to create a cloud is obviously the P cloud. Let's create it. Okay, let's remove the sphere. The P cloud, as say the name, is a cloud of particles. So let's see with the ticks. Let's use a different interface, and let's remove the grid using the G key. Let's maybe set a little bit more scaling and higher. Okay, then we can obviously change it. Particle generation, use a total particles, and let's say that we have maybe 25 particles or maybe less. Okay, let's go for 15 for the moment. We have no speed, so you see that we have no animation. Okay, so we have our cloud there, and I like to say that the size of the particles is 0, so we'll have no shapes inside the rendering. If we render, obviously you see that we have nothing. Okay, then we have to go inside the environment, and we need to say to use Pyrocluster. Okay, we know something about the interface and how to make the basic steps. So the first thing we have to do is to pick the particle system. Then we have to pick the lights. We can use the H key to pick the direct, and then we can pick for the moment also the omni. Okay, then first thing I like to do is to have the particle visible inside the viewport. So you see that's the scale, okay, and that's the shape, and we can see also later with the noise result. Let's go for the scaling. Okay, and you see that now it is bigger, but we need more particles because you see that there we have too much space. So let's say maybe 25. Okay, so we have a better shape. Let's go inside the environment again. We can see with a lower scale, but it's better to have something like that. And let's see with the hemisphere. Okay, let's see what happens if we try to render this thing in this way. Okay, we have a black series of volumes, so we have to go back inside the environment, and we have to say that we know we want to have illumination. So actually we have the illumination. Let's render again, and you see that we have a wide series of volumes. Then we need the shadows, so let's go there, and let's say that we have the cast shadows. So if we have some objects, we'll have the shadows done by the cloud, and we have the self shadows. Okay, and you see that we are starting to have shadows casting. Then we can start to have some working on the cloud. We can have, for example, more particles or bigger volumes. So let's see what happens if we have bigger volume, just a little bit. Do something like that, and we can squash a little bit more. Let's see. Okay, let's squash a little bit less. Okay, and we have the regularity. Let's see with less regularity. Okay, it is a little bit better, you see. And then let's see what happens if we start play with the shading. Let's make a copy of our screen and save. So let's see what happens if we change the scattering. Actually, we are using the isotropic. Let's see how to change the look using the anisotropic. Let's go back to the clone, and you can see the differences of illumination there and there. And maybe in any way it seems a little bit better, this one for clouds. But let's see how it change if we use, for example, the ray light. We are talking about all different way to shade, and also this one is not bad in this case, because I prefer the lighting and the area with no lighting there. Let's go there and let's see with HGS. And also this one is better, but for the moment I think we can go. I prefer to say something more about this illumination. First of all, the shading. We are not using the shading actually for the surface, because the foam shading is better when you are trying to simulate some volumetric effects for a solid surface. For example, I can think about the magma or something like that, because we'll have the highlights over the surface and we don't need it over gaseous effects. Then other things we can have are, let's go back to the isotropic, is the self-illumination. And we know that we are adding the self-illumination, and you know that we can have, for example, 25% self-illumination. So you see that we have more lights inside the cloud. So we are simulating in any way the scattering of the lights in a better way, but it's not so useful in this case, so we can go back to 0. Then we have the transparency there, and we are working in any way on the volume, and this is useful to control how the surface will works with lighting and transparency. So actually you see that with 0%, it means that all the area of the volume will be rendered with the same way. So if we have an area where we have no lighting, this area will be black and it will be rendered as black. If we say 100% and we render, we are saying that the area where we have no lighting will be rendered as completely transparent. We tried to simulate, let's hope, removing this light to see if we have. Okay, but we have not the good way to do it. So we'll try to simulate these effects on a future tutorial to work just on this parameter. So for the moment we can continue with the other things. And going back there, and we were talking about the scattering. So we have different ways. We have the isotropic and with the isotropic we have a complete simulation of the light scattering with no differences between the light direction, so it will be scattered in a uniform way. Then we have the anisotropic, and the anisotropic will not diffuse the lighting, so all the lights will go straight inside the volume and moving in the always in the same direction, so we have no diffusion of the lighting. The ray length is a medium between the isotropic and the anisotropic simulation, and the HGS is a different light scattering model. Maybe it's more advanced than the other, and it gives us the possibility to control the parameters of how much light scattering will be subdivided between the forward and the back area of the volume. So if we have the AGS and we can set to 0, for example, let's render, and we are doing a rendering just scattering in any direction. Let's see what happens if we have, for example, 100, so we have the light scattering completely on the other side, so you see we are scattering the light in front of us. And if we say 50, we have the in between, so we have a simulation that is similar to the isotropic lighting, so we have a complete diffusion in all way. So you have the possibility to control, and you have also the multiplier, so you see that we can control how much lighting is diffused inside the body of the volume, so you see we can have also less diffusion. So let's go back to the multiplier set to 1, and let's say maybe to have a little bit more diffusion on this area. So you see that's our shadows there, so we have a diffusion of our cloud in a different way. Okay, we worked a little bit on the illumination. We have no secondary illumination, so it's not a problem to play with it. And then we have the shadows. And so in this area, for example, we can play a little bit with the shadows there. And you see that we have there the initial steps. The initial steps give us the possibility to control how precise we have the shadows calculation. So if we have an higher parameter there, the rendering will be really faster, but the shadows will be wrong, and we'll have more artifacts. So let's see what happens, for example, if we have 1 meters as initial steps, and you see that we see nothing. So let's see what happens if we have 0.01, so lower than before. You see that it is really precise. We can try also to go down to have more precision during the rendering. Obviously now it's really fast because the volume is really simple, but with a more complex scene you can see the differences. This parameter can be changed until you see artifacts. So you can use an higher value until the artifacts will appear in rendering, and in this case you'll stop, but in this way you can speed up the rendering, and that's really useful. Another important thing is that this value must be more similar than you can as the rendering value there. So you see that we have an initial steps also there, and that's about the quality there inside the render. And there we have the same thing, because we are talking about the precision for the rendering, not just for the shadows. So with an higher level there, everything will be higher, so everything will be faster, but obviously the quality will go away, as you can see. And obviously step by step that we have a lower value, we start to have a better rendering. Let's try to use the same parameters we have inside the other value there, so 0.05, and you see that it is a little bit slower, but obviously we have back a really good quality. Let's check other things, and for the moment we don't need to control the limit. We can try to play a little bit with the falloff value for the shadows, but maybe we don't need it. We can see if we have changes inside the calculation of the shadows, but it's not so heavy, so we can stay with a basic value. We have the possibility to override the light settings for the shadows, so for example we can go there, select the light type, we can use the shadows map or the retrace. Let's save. We can use this one, the shadows map, and you see that there we have the resolution. Let's try with a really low resolution. You see that we have not so much detail. Let's try with a higher value. You see that it is a little bit slower, but we have gained back the detail. We have the same possibility using the ray trace shadows. So the calculation of the shadows will be done using the ray trace. Obviously, we have a lot more details of the shadows, so you see it's more precise than before, but obviously it is slower. So it is important to understand what kind of effects do you need to achieve, because you see we have 21 seconds for this result, and if we go back there, let's see how much time it will take. So you see that it's faster. We're talking about 4 seconds, and that's the result. So we have something similar, but you see that there we have more details. Obviously we can achieve something better there if we use an higher quality shadows there. So we can go, for example, to 2K. We can also filter the shadows to have a more precise shadows. You see that now it is calculating, and it is really slower than before to calculate the shadows. We have a really high detail, but we are still talking about just 13 seconds, and that's a really interesting thing, because we are going really fast. Let's go back to something more fast for our purpose. Okay, and save, but you know that you can play with it. And let's see something more that we can use. For the moment we don't need so much things there about the shadows, so you see that we have also splitted controls for the cast shadows over the other objects and the self shadows, so you can control the parameters in a separate way. We have the shape there, and you see that's our shape, but I like to see something about the shape there. We are using actually the turbulence, but let's see first of all what happens if we have, for example, the falloff. Actually we had no falloff, and now we try to have a more visible falloff inside our volume, so the border will have a better falloff. And that's, for example, let's make a clone. Let's go back to known and let's render, and we'll see the differences. So you see that there the border are more dense, and there we have less dense border. So here it depends on the result you are trying to achieve. Some kind of clouds can be more similar to this way of rendering, and some clouds can have more dense border, as in this case. So for the moment I can prefer this one, but you have to see what you need. So for the moment let's go for a cubic. We have then the density, and you know that the density gives us the possibility to control the cloud's density. Let's see what happens if we have a lower density. You see that the border are better than before, and in any way the cloud can be more realistic. But you know that we have in any case some clouds that are really dense, and we can use a higher value there, and you see that the clouds start to be really dense. We can also go really high to the density of the volume. So you see that the clouds start to have a really huge amount of detail, and it seems really dense. Let's go back to something between. So let's use 15. So we have something to work on. Okay, that's our basic result. And let's make a clone. I'm removing the old clone. Okay. Now we can play a little bit with the scaling. Actually, the size is 10. We can see what happens if we have, for example, 30 for the noise scale. You see that we have some bigger area than before and less detail. But you know that we can also add details, adding the details parameter. So we have a bigger general noise scale, and we'll have more detail inside this noise. So you can see that we have the noise size really high, but we have the detail there. We can obviously use a lower scale to something like 10 as we done before, and we'll have the same scale but with more detail, and that's another way. So you see that we have the same scale as before, but we have more detail. Obviously we can go lower, talking about the sides, and we can go, for example, at 5. And you see that we have more and more detail because we are using a really tiny noise scale. Let's go back to 10, and we can go for the detail maybe to 6 to be a little bit faster. We are using, let's say, we are using the turbulence, but we have also the possibility to go for the fractal, and we can see the differences when we go to render. You see there that we are using the turbulence, the fractal now, and maybe in this case you have to change the sides, or we have the advanced turbulence where we have also the levels to control. You see the levels of the turbulency, or we can go for the smoke. The smoke will be more similar to smoke staffs, so maybe we can stay, it is not bad. So maybe we can decide to stay with something like that, or we can stay with a basic turbulence there. In this case we have also, you see, the possibility to control the stretching, so we can scale it and have more detail stretched over one axis, as you see now. So we have a little bit of stretching, and that's useful. So you see that it is starting to simulate a cloud in a better way, and you see that it's not bad actually. Okay, so let's stay, for example, for a tree. We have the phase and the drift to animate it, and we can use in any future tutorial an animation about the cloud, and we can use the phase and the drift. We have also the bias, you see, to control the bias of the noise and the gain. So you see we can have, for example, an higher gain to have more detail between the area where we have more volume or less volume. So you see that we have more detail there and then more darker area there. But in this case, for the example we are doing, I prefer the 50-50. We have the control, you see, also with a low and a high value. So we can have a little bit higher value, and we should have a more dense volume where we have the cloud. So you see we have more white area there, and that's another interesting things we are doing. Okay, we have then the possibility also to have a noise static, but it's not a problem actually. Just to see, we have the possibility to control the fireball noise or the trend drill noise. So you see that in this way we have a fireball, so that means something similar to a ball, and in this case we have something more similar to some tendrils. Obviously, we have a control over the shape, and also this shape can be useful because let's think, for example, to use a 30. And we are simulating a different way to have the cloud, so we are something more similar to tendril, and you see that it's not bad. We can have, for example, a good scale. Let's imagine maybe 20. Let's wait. And this can be a really good looking stuff there for the cloud. So you see that we have this tendril there. Let's think, for example, to have a different point of view. That's the camera, but we can go inside the perspective. We can check, for example, the cloud from the ground. And you see that actually the scale maybe is wrong, because you see we have a lot of detail there, but it is not bad to have something like that, because if we go back to the fireball and we go for 15, let's see how it looks from the ground. You'd see that's the shape. The first thing we see is that maybe we have a not so good stretching there, so maybe we should have a little bit more less stretched, so something like 2. Okay, from this point of view we can see better the scattering, so we can go back there and we can think about what happened if we change the scatter there, the coefficient, and we'll see, for example, to have less scattering. You see that there we have more a darker area where we have the shadows. One thing we can do is to pick the omni and going for a little bit less lighting. Let's try with 0.35. So you see that now it is darker. Okay, if we go back to 7, you see that we have again a better distribution. Let's see what we see also from other point of view. So for example, from there, you see that we have a really dark area because we stay on the other side of the cloud. So depending also on the side we are checking, we have to work a little bit with the shadows value. So let's go back to the camera. And we are back to our point of view, and we are playing all obviously to work on this side. I'd like to go back inside the environment in Pyrocluster, and I like to stretch a little bit the shape again. And a little bit more scaling. Okay. And just to know, just a little bit of gain. The only thing I can see is that there we have too much visibility of the shape done by the sphere, as you see. So maybe we need to use the less stretching. Sorry, there it's okay to have two. I mean the squashing. So another interesting thing will be also to use different scaling for the volumes. So you can use some value inside the Pyrocluster to control the scaling there. So I mean, there you see that we have the scaling. We can use the particle scale, but we can imagine to have the radius, and but it will be interesting to do something like that on a more complex tutorial. So and you also know that we can create a custom shape for the cloud. So let's say that for the moment it can be a good basic for a cloud, and we can obviously, for example, have a copy, let's say clone, and we can, for example, move it there, and this one can have a new seed for the position. It can be a little bit bigger, and then in Pyrocluster I have to say to use also this one. So we have to go there, and we have to pick also the second one, and we can check what happened inside the rendering. And you see that there we have a really looking shape for the cloud, also there for the shadows. So that means that actually is not bad. We can think, for example, then to have other clouds there, and let's say that this one will be again bigger. You see it, and it will be something like that, and it will be higher, and we can move it there. Then sorry, for example there, and this one can have more particles, let's say 35, and let's check if the light is big enough. Obviously not, so we have to scale it, and we have to pick there. Let's pick the light and the target, and we can move to the center and then back there, and we say that it is bigger, and we have still the overshoot, and let's see what happened. But I have to say to use the particles there. So inside the environment, peak, also this one, and maybe it needs to have more particles, right? So back there, and it must use more particles to have a bigger volume. You see, we have more details now. And now we try maybe to have also a cloud there, really near the camera. We can pick this one, edit. Now first of all, let's save. Okay, edit, clone, and we move it really near the camera, for example there, and let's say to Pyrocluster to use it too. Okay, and maybe we can move a little bit out of the camera, but near. Let's zoom in this area. And let's see how it looks. So there it is working. Here it is working. And there we are really near to the cloud, as you can see. And you see that we have this volume there. Obviously in this case we have the possibility to see how it looks. So let's see what happens if now we have the tendril settings. So let's select Pyrocluster again, and let's say to use the tendril inside the noise and render. In any case, you see that it is a little bit better because we have more interest in the tail on the side of the cloud. So you have just to understand which is the result you are trying to achieve. So we saved the settings, so I can, for example, select this area, and we can make some playing with the environment. We can think about to have this one, and we can think about to have a bigger scale there, and we can think to have something like that, and let's see how it looks. So you see that we have more detail on the cloud, but we have also less dense area, and that can be obviously more and more visible. So you see, I'm changing the volume, trying to achieve a better result, and that's not bad actually. Let's save this version, and let's see what happens if we have a bigger scale. Let's try with 35. So you see we have bigger detail there and also there, and maybe we can add a little bit more detail. It is just a test, so maybe we have to go back to the first version we done. Maybe it must be just a little bit more little. Let's try with 30. Just because I don't like to match this area there. But now it is better, you see, because we have more detail. Let's see also in this area. You see that it is not bad. We should play a little bit more on the area where we have the shadows, and we can see, let's say, if we have a little bit different control, if we have a better look or not regarding the lighting. You see that we have more light area there, but I don't like so much this area. Let's see with the isotropic. I prefer this way. It is not so good there where we have the shadows, because we have a really so visible shadows. But let's see, for example, there. There we have more shadows visible, but we can change a little bit the coefficient. And there it is too much light. Okay, so let's try to change something there. Let's try to go back to there. We can go back to our settings for HDS 6E, and we can have maybe a little bit less scaling for the volume. Let's see what happened. Okay, we have not so bad result there. Let's see also this area. It is not bad. And we can have maybe another cloud there, as this one. We have to say to Pyrocluster to use this one too. And let's see what happened. And you see that we are inside the clouds, and we see some more clouds in the sky. We can check a lot of things there. Just you see to add more details. Maybe a little bit less stretch. So you see we are adding more details inside the volume. But I mean, we can say that it's not bad as result. It was really a simple test, and you see that it's not bad. So, you know, we have a lot of possibility inside Pyrocluster. So that's just a test about how to prepare clouds, but obviously we have thousands of possibility using the parameters to have different simulation of clouds of any ways, and obviously you can use also different way to prepare the basic value and particle system to have the clouds, and we'll see more tutorial in the future to see how to prepare it with pflow, thinking particles, and also the basic parameters. And we'll see, for example, how to use texture to control the noise the cloud presents. So I think that for the moment that's all. That's our result. It's not bad. It was really simple to achieve. And I hope to see you back on Max Cookie to check for new tutorial coming from cgcookie.com. Bye.